Now for the rules of probability, let me talk about Venn diagrams. There's three type of cases. Let's represent each circle represents a probability. Sometimes they don't share anything in common. For example, what's the probability of a number being odd? What's the probability of a number being even? Right? It's either odd or even, but there's no in between. There's no number that it's both. So we could see this case. Another case we could see where part of the list is shared. Imagine I came in and said, what's one of my circles represents even numbers, and another circle represents the numbers from 1 through 10. So there are numbers that are even, but not 1 through 10. For example, 12, right? That's an even that's not 1 through 10. There are numbers that are 1 through 10 that are not even, like the number 5. So let me write this real quick. Let's say my first circle represents even numbers, and my second circle represents the numbers 1 through 10. So I could think of an even that is not 1 through 10. I said the number 12. So notice how it's inside the circle of even, but it's not inside the circle 1 through 10. I could also think on this other side, the number 5. It's a number 1 through 10, but it's not even. There's more numbers. I'm just doing an example of each. And then in between, right where the two circles shared, let me think of the number 4. It is even, and it is also 1 through 10. Again, there's more numbers on each circle, but that's basically what my Venn diagram means. And now here on the first one, I said, think of odd or even, right? There's numbers that are odd, there's numbers that are even, but they don't share anything in common. Now we use the last case we call the subset. Let's say the numbers even, my circle here, it will be even. And let's say my big oval here, my big oval, I will call this integers. Whoa, integer, what is that? Basically, that's all the whole numbers, positives and negatives. So all the evens are integers, right? So notice how the whole circle even, it's inside integers, because I said integers are all the whole numbers. I'm not including decimals, all the whole numbers with positives or negatives. Okay, so this is what my Venn diagram will mean. A couple of rules we're gonna be looking at. When I use the word and, we're gonna multiply it. So for example, if I say the probability of A and the probability of B, so two different probabilities, but I use the word and, I'm just gonna multiply. This is probability of A times probability of B. When I use the word or, we're gonna add. So what I mean with that is probability of A or probability of B, right? Two different events, going to be the same thing as probability of A plus probability of B. So difference between A and or. Now there's a conditional probability. Interesting. Conditional probability means that something happens. So let's say probability A and B. I'm going to use the little line. I'm going to say probability of A given B. So I gave you the condition that B has to happen in order for probability of A given B. The way we're going to say this, we're going to say probability of B given A times the probability of A divided by probability of B. Now, two cases I'm going to use, dependent or independent. Let me just talk about them. I'm not going to write anything. Dependent versus independent. Now, two events, I'm going to call it A and B. We're going to say they're independent if the knowledge that one occurred does not affect the chance of the other. All right, so probability of A and B are going to be independent if probability of A and probability of B do not affect each other. For example, I don't know, let's think of the rolling two dice. Right, I'd roll one dice, like I get 1 through 6. Whatever I get on the first die does not affect the second die. That's what we call independent. Now, dependent, the probability of one event does affect the probability of the second event. Let's say I have 5 coins. Let's say I have 2 nickels, 1 dime, and 2 quarters. Probability of A, I grab a coin and I don't replace it. Well, that will be effect, and then probability of B, I draw second coin. Well, whatever I get on the first draw will affect the probability of the second one. So that's what we call dependent. Now, mutually exclusive, two events are mutually exclusive if they cannot occur at the same time. This means that A and B do not share any outcomes. What's the probability of a number being odd? Probability of being even, right? These are mutually exclusive. They cannot happen at the same time. Now, two symbols I'm going to be using. This thing that looks like a U and this thing that looks like a U upside down. Now, the U, we're going to call that union, okay? Union is basically combining the two probabilities together. So if I was looking at, let me do this as a green. If I'm looking at the second example of my circles, probability of union is basically everything. All the two probabilities combined. Now the probability of a U upside down, this thing we're gonna call it intersection. Now the intersection is only the section that they both share. So remember, the intersection is the space that they both shared, only the space that they shared. Union is basically everything from one and the other. Okay, so let's take a look at some examples. Find the missing probabilities. Find probability of B, probability of A and B, probability of A given B. Okay, now one thing on conditional statement, I know the probability of A and B it's equal to probability of A given B times the probability of B. Now I can change things around. Another rule I can use is probability of A and B. It's equal to probability of B given A times the probability of A. So depending on the information that I give you, but I'm going to use the first formula this time. Okay, what's the probability of A and B? Well, 12 out of 25, right? Okay. So 12 out of 25. But what's the probability of A given B? I don't know. So I'm going to call it X. I learned that when I don't know the value of something, I call it a letter. What's the probability of B? Well, 3 out of 4. All right, so let me divide both sides by 3 over 4. We know how to divide fractions, right? 12 over 25. For right now, let me do slow motion. 12 over 25 divided by 3/4 is the same thing as 12 over 25 times 4/3. Remember in division, we change it to multiplication. We do the reciprocal of the second fraction. Now I simplify, and this is going to give me 16 over 25. Because look, I went, this is 4, this is 3. I divided each by 3 here. Oh no, this is a 1. So 16 over 25. That's it. Okay, now here on this other one, probability of A, probability A or B, probability A and B, and what's probability of B? Oh man, this can be broken into Venn diagram. Probability of A given B plus probability of B equals probability A or B. Okay, so one of my Venn diagrams I could do is probability of A given B plus probability of B. It's equal to probability of A or B. Some of you might be wondering, what in the world is that? Okay, let me explain. Let's say this is A and this is B. So probability of A given B. So looking at your circle B, what is A inside of B? That's this one right here. Probability of B is the whole thing, and then probability of A or B. Oh no, probability of A given B is this part. Probability of B, is this part. Probability of A or B is basically the whole thing. So it could be broken like that. Another case, it could be broken into, I'm gonna go probability of A or B. Okay, so what is probability of A or B? Is basically the whole thing, right? It's gonna be probability of A plus the probability of B minus probability of A union B or intersection B. That's this space right here, right? Why do I have to subtract it? Because when I counted probability of A and probability of B, I basically counted that space twice. That's why I'm going to subtract it once. Now, probability of A or B, I know what that is, right? Probability of A or B is going to be 53 out of 100. What's the probability of A? 7 over 20. What's the probability of B? I have no idea. That's what I'm solving. What's the probability of A and B? It's 7 out of 100. My first fraction here, 7 over 20. Let me call that 35 over 100. Because I know for subtraction, I like to do common denominators. So I'm going to end up finding, let me move this up here. I have the 53 over 100. It's equal to x plus, okay, what's 35 minus 7? That's 28, right? So 28 over 100. You're like, where do you get that? 35 over 100 minus 7 over 100. I moved my first fraction over 100 because I was going to combine fractions. I needed common denominator. Now let me subtract. So minus 28 over 100. I know 53 minus 28 is 25. So that means that x is 25 over 100, better known as 1 over 4, which is also known as 0.25. Good. Fraction or decimal.